So I guess I've always been interested in more outdoorsy types thing for Miami girl. So I'm from Miami and I do like to get out in nature, and so I've always been interested in science. I decided to go in the direction of ecology because I prefer natural systems versus systems that you really focus on the people. For my PhD project, I decided I wanted to work in the Everglades. It was an interesting place to work. They had recently installed these eddy covariance towers, which measure atmospheric fluxes of carbon and water in and out of a system. And so I thought it would be cool to work in this area where they have multiple flux towers, because in that time, in the olden days, that was rare to have a site that had multiple flux towers, and so you can just tell so much more about systems. And so I thought that the project would be great. A part of my PhD project, there were a series of 4 different studies that I did, and one of them was, of course, looking at climate change. And to me, that was cool because I got to look at all the different guesses for what the future might be like, and then figure out a way to put them all together to project what that means in terms of how the system will function in the future. So it's really just a creative exercise to say that if 100 years happen right now, what would the system function like? And so that's what that paper is evaluating. Well, one, I had to. I was in a PhD program, and so you have to come up with a number of different questions that you want to explore. And for me, I chose this site working with eddy covariance data. And so I knew that I had to develop questions that I can answer with the data set that I had. And so I made a list of all the things that I'm interested in. I'm interested in disturbances, climate change. I like to think about the future a lot, so anything that lets me guess what the future might be like and how the systems might function, I really like to work in that realm of, there's a lot of guessing involved. And so if you look at the article, it uses data from 2009 to 2012. And so that's when the data was collected from the sites. And so you could say that starting back in 2009 is when the information for this article was being gathered. But I actually didn't start my PhD until 2011, and so those numbers would not line up. And so the data was being collected. I decided to use the data set starting in the first full year of data. So these tower sites were installed in 2008. And so I used from 2009 to 2012 of data collected. But if you look at that, 2012 was the last year of data, but the paper was published in 2015. And so you are working on a paper until it is published. And so it took from about 2009 with the data collection to 2015. It's a long process. I think that it took about a year. That paper, let me see, I think we published that one. So this was in Ecosphere, and they're kind of notoriously slow. And so this paper was received in October of 2014. We had revisions in 2015 in January, and it was accepted after the second review. And so it took from about October to January. Paper writing really starts way before you actually think about writing the paper. That's like the last little thing you have left to do. And so it really starts with coming up with something that you think is interesting. And so you'll design an experiment, whether it's observational. For me, most of my experiments are observational. I have equipment that's out in a system, always taking measurements. And so whenever something cool happens, I'm like, yes, hurricane's coming. Yes, hurricane's coming. I'm going to get some information about how the system responds, And so I pretty much have to wait around to see what happens to then say, okay, what am I going to focus on. And so for this paper, I just took a period of time where things were pretty normal. And that's good because you get an idea of what the base system acts like under the normal climate conditions. And then if you know the relationship between how small changes in weather, temperature, precipitation leads to changes in how your system is functioning, then you can take that relationship and project it. So if the climate changes by 10%, how do the fluxes change? And so you can estimate those types of things. And so I usually start with, this particular system is really interesting for these reasons. And so for the wetlands, they're interesting because they have a lot of carbon in the system already, but we've changed so much about the system that we're not sure that the system will keep that carbon or release it. And so we're already releasing carbon into the atmosphere. And so we don't want natural systems to be degraded and release even more carbon, because that's just a bigger issue in terms of greenhouse gases and increasing radiative forces. And so with this project, I started by choosing a system that's really interesting, and we put towers out there, and then based off of the things that happen over time, we can develop questions. And so for this paper, we focus on, well, what are the climate relationships? If temperature increases so much, how does that influence how much carbon is being taken up versus released? And so it's just I focus mainly on observational studies, choose really interesting systems, and then come up with questions over time based off of what has happened in the system. And then once you come up with your questions, you can design your study, decide how much data you have. Do you need to contact people from other similar sites to get even more data? And then do your analyses and sit down and write the paper, which usually happens over about a year. It takes to write a paper, and then you submit it, and then other researchers have to be chosen to criticize the work and think about what can be done to make it better or worse. Is it really enhancing science to publish this paper? And so they'll go through all those questions, and they'll send you a bunch of feedback, and then you'll have to respond to the reviews, make some corrections, make it the best that the paper could be. And then if a journal approves of it, they will submit it. And if they don't approve of it, they will reject it and tell you to take it somewhere else. And journals have very specific views on certain types of research that they're interested in publishing, because they have an audience that they want to support. And so sometimes you'll think that you're writing a paper for one audience, but it's better for another. And so you'll have to a journal will reject it, and then you'll have to go to a different journal that may be more appropriate. And so it's an iterative process. I think the hardest part whenever you're trying to think about the future is limit yourself to what the future can be. And so when I was thinking about all the things that could happen in South Florida, some people say temperature is going to go up. Some people say it might go down a little bit. Precipitation might go up, it might go down. It might go up, but it might only go up at one time of the year. And so you have to, from all the information you have and all the projections that climate scientists have come up with, you have to figure out which ones can you explore, right? Because to run a model for every single projection would just take forever. And you generally have to complete your PhD within a certain amount of time. You have more than one chapter. And so you have to decide. And so you'll see in that paper, the futures that I decided would be most interesting was the middle ground, where you have very moderate changes, and then two extremes where you have a significant increase in temperature, decrease in precipitation, and then a significant increase in precipitation, to kind of get an idea of all the possible futures. And so you get a middle ground estimate, and then you get two extremes, and then you would expect that whatever does happen in the future would be somewhere in that realm. Well, the results happened pretty quickly. Mm-hmm. With the model that I chose, the DACENT model, you get results pretty quickly. And so you can run the model Once you design what you want the future to look like, it just takes maybe less than 10 minutes to do 100-year run. And so you get results very quickly. The biggest part is just designing what you think the future might look like and figuring out how your system actually responds currently. And then once you figure that out, to do the projections is the easiest part. My most interesting, so I really like disturbances and how systems respond to disturbances. And so the last few years I've been playing around with the current force types that exist in the US. And those force types are likely to change for several reasons. One being a lot of Western forests are what they call ghost forests now, where all the trees are dead, or like 80% of the trees in the forest are dead. And so there's a huge opportunity to figure out what is going to happen with the species that we have left that are in close proximity to those forests, how quickly they're going to fill in, how the forest is going to change. The interesting part is with these ghost forests, unlike other times where a forest is destroyed, let's say a fire comes in, it actually removes the trees and opens up the area for other species to come in. But with these ghost forests, the trees are dead, but they're still standing for now. And they're likely to be standing for, quite some time. And so the trees that will come in to a forest like that will be different than what we're used to. And so you get to play around with all these different projections of which species would do well under these conditions. You have to consider the climate, the microclimate because of the standing trees, light limitations because there's still all these standing dead trees everywhere, and just figuring out what that forest might look like. And so I really like the interaction of the disturbance and then figuring out what the possible futures could be for the species that are in that area.